Alright, I'll run through this relatively quickly. We will have a quiz tomorrow, and it'll look just like this one. But here's the solutions to this. You can ask me questions tomorrow about it, but this way you get to... we just have to... I got paused there for a second. I'm not sure why. But anyway, here we go. I'm going to match definitions with the number set on the left-hand side. So natural numbers. Remember natural numbers? Those are 1, 2, 3. So they're positive numbers, but not negative numbers, so it's certainly not A. A number that cannot be expressed as a ratio, well, I can write 2 as 2 over 1, or 3 as 3 over 1. Those are ratios, so it's not B. Counting numbers, I really like that because we usually start with 1, 2, 3, so those are what I'd call my counting numbers, would be natural. The whole numbers, now we add 0, so counting numbers including 0, that's E. Integers, this is where we add the negatives in, so it looks just like the naturals, but we have 0 and -1, -2, -3. I should have written those in the reverse order, so I go from smallest to largest, but that's fine. That's A. A rational number, a number that can be expressed as a fraction, D. And irrational then is, by default, B, things you cannot write as a fraction. This is classified now negative 19.89. If it's a decimal that ends or has a repeating pattern, you can write it as a fraction. Okay. Now we got to circle everything that is correct. It's not natural, because natural is like counting numbers. It's not whole, that's counting numbers plus 0. It's not an integer, that's all the positive and negative counting numbers. But if it ends, it's a decimal, it is rational. So you know it's a rational number. And the last one on this slide here, classify pi over 2. Well, pi is irrational. If I take an irrational number, this decimal that never ends, divided by 2, I get half of a decimal that never ends. So it's still going to be irrational. Alright, starting with number 8 next. Here we go. Classify 18. 18 certainly is a counting number, which is natural. It's a whole number because that's included in the naturals. Whole numbers are the same as the naturals, except the wholes have 0 in them. Well, 18 is certainly then, if it's in the naturals, it's in the wholes. Integers, all the plus and minus whole numbers. It's rational because I can write it as 18 over 1. I can also write it as 36 over 2. Okay, as long as I can write that number as a fraction, but it's not irrational. So it's A, B, C, and D. These are a little bit tough to see. Hopefully on the graphs on your handout you could tell what they were. We just want to show how we would do this addition problem if we did it on the number line. So -7, for example, means go 7 to the left. So if you look at A here, it starts at 0 and goes 7 to the left. Then it goes, it looks like 2 more to the left. Well, the original problem basically said 7 to the left, the negative, and then it said 2, let me grab another color, to the right because it's a positive 2. So I want one that goes 7 left, then 2 right. So let's look at these. It looks like B does that. It goes 7 left, then it goes 2 to the right, and the final answer is how far am I from 0, which is going to be -5. I'm 5 to the left of 0. 10, this one goes left 2. So I'm looking for one that goes left 2. Then I want to subtract -4. So I'm going to think of it this way. Left 2 plus 4. That double negative. So if I take a look at these things, I have this one goes, let's see here. This one goes left 2. This one goes left 2. C then goes plus 4 to the right 4. So my answer is a 2 right there. And we can see the answer is 2. So C is the correct choice. 11, now we're just doing math. You can use your calculators for these things if you have a hard time with this stuff, but that's just -6. I got 9, I take away 15, then I'm at -6. -4, -9, -13, -8, got this double negative right there again. Okay, so that's -8 plus 12, which is a +4. -12, take away 15 more, I get to -27. 15, I have to do three numbers. I've got negative 10 plus 18 plus 5, that double negative. So I usually do whatever math is easiest. I'm going to add these first two. That's an 8 plus 5. That's 13. Is this thing true? Subtraction is commutative. So in other words, if I have 2 minus 3, is that the same as 3 minus 2? And no, it is not. Okay, because 2 minus 3 is negative 1 and 3 minus 2 is positive 1. And some people might make the argument that, well, hold it, subtraction is the same as addition, so you could write 2 minus 3, we'll call it plus negative 3. Is that the same as negative 3 plus 2? Yes. Those two are equivalent to each other, but this is addition. So addition is commutative, subtraction is not. And it's not because of that right there. We got some evaluate problems. I got 8 times negative 7. That's negative 56. Double negatives multiplied together. That's going to be a positive. Now I've got 3 negatives multiplied together. 30 times 9, it looks like negative 270. 258 divided by 6. Now I know they're negative, but I know if I divide two negatives, I get a positive. It's going to be 3. 18 divided by 0. This is kind of a tricky one. Try that one on your calculator. You cannot divide by 0. And so we just cannot do that problem. So what we label it is undefined. There is no definition. Undefined. Okay, so you can't divide by 0. Next one, 72 divided by negative 8. Answer will be negative, and it will be a negative 9. Negative 10, if I square it, negative 10 times negative 10, positive 100. This one's tricky. I want the opposite of 9 squared. Well, 9 squared is 81, so it's negative 81. Try both of those on your calculator. You will see they give you those answers. In the first one, 23, the negative sign is seen by the square. In the second one, number 24, that square does not see the negative out front. Think of these parentheses, kind of like eyeglasses, and they say, what does the 2 see? This 2 sees the negative and the 10. Takes negative 10 times itself. This 2 just sees the 9 because it doesn't have these parentheses, those glasses on. 6 cubed, I think, is 216. You might want to check that. And finally, 2 cubed is 8, because we got to do exponents first. 7 squared is 49. And so that's 72, carry your 7392, I believe. And finally, the very last problem. The Algebraville Clothing Company, clever name, made a profit of $150 on its opening day. So $150. Is this right? I thought I had a different problem than that last time. Gosh, I hope I have the right quiz. 150 on the opening day of business. Then it lost $275. And then it made $200 on the third day. They started with $150 in cash on opening day. How much did they have at the end of the third day? Alright. So let's figure out this total for those 3 days. That's negative 75. And then those, I'm going to combine the 150 and the 75. That's 75 right there. But they started with 150, so they end up with $225 at the end. If we include the cash they started with. At the end of the fourth business day, had $275 more than it had at the beginning of the first day. Well, at the beginning of the first day, they had $150. Remember, they said that. $150 on opening day. I had on the beginning of the first day. Okay, so we'll add $275. $275. That's $2, $3, $4, $25. What was the outcome of the fourth day of business? We just have to add this $225 220. No, we can't add the 225. Because this is how much they had. What was the outcome of the fourth? What was the outcome of the fourth day of business? Well, here's day 1, day 2, day 3. That adds up to 75. So, if we look at this 275, at the beginning of day 1 they had 150. Now, at the end of the fourth day they have 275, so we'll subtract those two, which gives us $75, right? 5 minus 0 is 5, 7 minus 5 is 2, no, gives us 125. So, what was the outcome of the fourth day business? 125 there. I think on the fourth day, they should have had 225 after day 3. If they only end up with 125, they lost money. I'll have to check that one in class.